Everyone, September 27th. Alright, yesterday was bad. So bad that we have to do this again. So, binary search tree doesn't work, which I think mainly because the reset process is it just doesn't work. It's too complex. So I didn't really check the solution carefully, but I saw at least we have the method of line sweep. So that could be a method I'm gonna try. But there's also another way, which is doing exactly the same as binary search tree, but we use the tree map. And when we use the tree map, there is a benefit of we can create a copy before. I'm not sure how much penalty and performance is going to be, but we can always create a copy. And actually it can be a shallow copy because everything is just key. Oh, actually it's not going to be a shallow copy because you need to save both the it's not exactly you have to create an actual copy. So I don't know how costly it's going to be, but we can definitely do that. We save a copy and then we insert a new range, and then if anything goes wrong we just throw away the new one and then we keep the old one. So that will be better than going with a binary search tree. It's easier to revert back, but we're not going to try that. I'm going to just try the line sweep idea. And I have an idea of how to do line sweep. We use tree map still, but we have that. I have that idea to do line sweep, and we'll try that. And of course, we have to check the solution. So now we have two problems. All right, two problems kind of getting stuck. Yeah, this really doesn't doesn't look nice. And I'll probably have. I shouldn't do it in Python actually. Do we have that in Python? Yeah, we have it in Python. We should have go with the other one. Ah, well. Anyway. Alright, today is design circular deck. Okay, done this before. Design your implementation of the circular double-ended queue. Have a circular queue. Initialize the deck with a maximum size of k. Insert front adds an item to the front of the deck. Returns true if it's successful. Insert last adds item at the end of the deck. Return true if it's successful. Delete front, deletes the front. Delete last, get front, get rare, is empty, is full. Circular deck. What do you mean by circular deck? So it's like a circle, right? So this one I says 3. So basically we have 1, 2. Goodness, 1, 2, 3. And then if I have pointers. In fact, usually isn't this just done with pointers? Right, we have front and end. Okay, we can say F and E. Right, and then we say insert last. Okay, so I put 1 here, insert last. Let's say circular, right? So now E comes in here. Right, now E comes here. So front and end point to the same thing. Can front and end point to the same thing? I guess it can. Because if you do a front, it has to be here. So front and point is the same thing. And then we say insert front. So 2. Then front move forward. How about the end? I don't know. What do you mean by a circular deck? Basically just need to keep track of where is the end. And then insert front. Insert 3. Now front come here. But it's occupied. And then do 4. Insert front. No, now it's get. Wait, hold on, what? One, two, three, 4. Yeah, 4. Insert front. 4. Or insert last. Or 2 insert last. Trying to do it again. Okay, so let's just do a circular, right? It's a circular. So if I say this is the front and this is the end. So insert end is 1, so end is gonna come here. And I say insert end 2, the end come here. Front should come here too, right? Because next one is insert front. Is also true, so front come here. So insert front, and then, well, both front and come. When do we know that it gets empty? So usually isn't the two like meet each other? Or do we need an extra to place them? If I say the front will always pointing to the next available, right? And the front has to be or maybe we should do it this way, right? I don't know. Help me understand. If I say end is here, front is here, right? So front can push, 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 push. If front meets end, that means we have filled everything. What if end meets front? Hold on, it's different. Front and end. Front is end is front. That's the thing. We only need a one pointer, I think. Because it's the same thing. Right? I just need an index here. And then this is index pointed to the front. And the end is always this one minus 1 and then you mod, right? So we have end, we do something. And but how do you know that it has been filled? Because you can set it to some value, right? So you can set it to a negative value. And then when you set some, you always move forward. Okay? This is the front, this is the end. And then you do 2. You say you move forward. And when I say the front is occupied, but the end, no, front is not occupied. Enjoy. Now front is not occupied. You can. No. I still don't think that's right. Hold on. Capacity is 3. It doesn't mean that you need to fill at the end. No, we start. So let's just say capacity is 3. So front and end, we start at the same. We start at the same spot, right? And then yeah, because start is nothing, right? And then you add something. Right, you add, okay, we add 1, there's a tail, and then you add 2, right, and then in the front, you add 3, and then you want to add 4, but you cannot. The queue is full. Get rare is full. Delete last. Insert front. Get front. So basically it means if you fill it, is fill it. But if you delete it, you can add it both on front and both on end. That's what it means by circular. Okay, that's what it means by circular. Well, we can definitely do it in linked list. Right, linked list is a way, so we can always do linked list. Actually, maybe linked list will be the easiest way to do this, but okay, we can solve it in the linked list, but I still want to see if we can move the pointers around. But how do you move the pointers around, especially in deleting? Well, in deleting, you just say, you know, the pointer gets moved back, right? The pointer gets moved back, and yeah, and then yeah, delete and move back, and we say I need to add front. So front need to point into that position. How do we handle this? Especially with front and end, and they cannot point into the same. How about they point into an empty space? Let's say we have, this is the empty space, so front is here, end is also here, so end need to go backwards, front need to go forward, right? And then end, and they're both in this position. They're both together, right? And the end come here, so 1, and n is here, so n is going this way, right? N are going this way, and then end, okay, n is here, as e is pointed to the end, and then We do 3. So now front pointing here. Right? And then what? So front and end, if they pointed to the actual thing, and if end is larger than front, yeah, they're facing each other. That means it's full. How about the other way around? Yeah, so in this case it's full because we can now go. And then we say get rare, basically we just get this is full, delete last. Delete last, we move this one here. Okay. And then insert front. So this becomes 4. F comes here. Okay, what if we keep going? Like this is also full, right? And then if we delete again, if we delete n again, so this shall go inside. Does E come back here or does E go inside here? That's a good question. I actually don't know. Because we can keep going, right? Because we front is at 4. We have 4, 3, 1. E can keep deleting. So E shall be pointing here. Alright? If I delete this, E shall be pointing here. And if I delete again, then E shall be pointing here. Right? And then we add E go this way. And then can we delete one more time? Yes. We can delete one more time. But if we delete one more time, then if E, we just stay here, right? And then what do we do? We set them to, we can set them to -1, which means it's empty. Yeah, we set them to -1, means it's empty. Because they are together means we only have one element, right? And if we delete it, we set them to -1. And then we insert, if they are both -1, yeah, insert it as a front, we put that to 0. If it's yeah, it's just a special case. If it's a -1, then what if my F, we fill all 3, right? F is here, and we need to add an E. Or we can set, actually I don't know, we need to add something at the end. Because we need to put E here, right? We need to put E here. E need to be outside. We need to put E here. Maybe we should start put F and E both on this side, right? Then we say we add 1 for F, not add 1. So yeah, we both are here. Means front and end are both are empty. Yeah, and then we add 1, so F goes in here. We fill it up. We put F here, so it's always pointing to the current. then if we go back, e will minus 1, f will just mod, don't plus 1 mod. See, that's the thing. If it's fe, we say that means it's full. But what if f is here, e is here? Because f front, wait, isn't front thing going this way, right? Yeah, f front. Yeah, front should go this way and should go this way. So okay, so when we add front, we put it here, we add end, we put it in here. Right? So we add end. So end regularly should go to the right, front should go to the left. So initially I can say f and e some regular number, weird number. And then when we say insert last, okay, we set e is 0, we insert last. F is still somewhere else, right? If f is somewhere else, that just means we have nothing in front. And then we insert again. Then we insert front. Okay, insert front, f is outside, so insert front always going here, right? This is the first one we check. And then we just check e and f. Because e is going this way, f is going this way. Right? As long as e is smaller than f, we're good. Right? As long as e is smaller than f. If e is equal to f, that just means there's no position. Right? Yeah, they cannot be equal. Equal means this is not possible. So I'll put 3 here, now we'll put f here. Right? And then we need to check, yeah, and it's bad. And then we need to remove last, so e goes here, right? So now, as long as e is smaller than f, we're good. And then the amount of difference, and then like if we, okay, now this thing, if we delete again, right? E delete again, where is e? Right? So we keep delete, e shall come back, right? E shall on here, but e and f cannot be on the same, which means if we have a long thing, right, like e is here, f is here, so we have, these are empty space, and then I delete, okay, so I here and I delete this, and I can come back here, right? This is what the end is, right? Now we say e has to be smaller than f. How are we going to reconcile this? Because front is here. Yeah, we're gonna try to add this way, right? Front goes this way, and is going this way. So what is the space in between them? These are just the front. Now become end, right? This just become end. Right? It just become end. So it must be e to f. In this case, e to f, we have a lot of space. Right? We have lots of space. So I can keep going, I can keep deleting. Right, I can delete, so we have that many space. Then what? Then now I have 2. Then I delete again. Right? If I delete again, then they are the same. They point into the same thing. Right? They point into the same thing. Now you just said they cannot point into the same thing. Right? They cannot point into the same thing. But if it's deletion causing them to point to the same thing, where is the tail now? At last. If we only have one element at front and at last, it doesn't matter. We can go either way, right? We can go either way. It really does not matter. So when E and F are the same is when there's only one element. Is when E and F are the same, right? If only we have one element, E and F is the same. And when we start, so we need a state where it's an empty. That's why I say I set E and F to some weird values, right? If they're in the weird values, then they're empty. And then when the first one comes, no matter it's insert front or insert last, E and F will go to the same position and then put the same value, because the front and end point into the same thing, right? And then you add, right? You add to the end, so E keep going, E keep growing, you add, and then you say you add front, so front jumps to the next, right? You go to front, so front is going to go this way. So yeah, if the front want to go and it hits E, that means we don't have enough, right? That's it. Now when are we E is the same thing, and now we reduce, or to the front, right? Because N is going this way, front is going this way. So when we delete, right, it's when you delete causing E and F get into the same, that's allowed. If you're deleting and they merge together, that's allowed. But if you are adding and they both merge, that's not allowed. So if you're deleting, they merge together, that's allowed. And then if you delete again, then you set them. Okay, so I think we have an idea of how this one should be done. It took a long time too. I think it should be 27, right? Oh no, I think it should be 28. Yeah. Okay, so here's the idea. Int deck equal to new int k. Okay, f equal to -1, int e equal to -1. All right, so when they're -1, it's oopsie doozy. All right. Now what? Oh, now we have k. Actually, we don't have this. All right, so we can say this dot deck is a new int k. Okay, insert front. If f equal to -1 and e equal to -1, then this is empty. Or we can say if is empty, okay? If is empty, then we say f equal to 0, e equal to 0, and this dot deck this dot f equal to value and return true, right? If is full, right? If it's full, it is return false. Otherwise, then we have space. Now we insert front. Then we just say f equal to f plus 1 mod this dot deck dot length, right? We just move forward, and then this dot deck this dot f equal to value return true, okay? Insert last will be the exact same logic, right? It's the same logic. If it's empty, we do, and then we say e. If it's full, otherwise, no. Front is -1 plus this dot deck dot length, right? This is e. This dot e, right? And then, okay, this is insert last, so delete front. If is empty, return false, right? Otherwise, delete front. So f equals f plus 1 mod dot deck dot length true. Same thing, delete last. So it'll be e minus 1 plus dot deck dot length. Okay. Get front. If is empty, return false. I'll return this dot deck, this dot front. If it's empty, oh, it's not return. Oh yeah. Return. Wait, hold on. Return what? -1. So this is the most difficult. Empty. We need a little bit more things to do here. Yeah, well, we'll deal with this. So this is just a return this dot f equal to -1 and this dot e equal to -1. Full. E going to the right, and f, so will be f minus e. So f minus e plus this dot deck dot length mod this dot deck dot length. They only have one. And then we can imagine is full. So the delete delete f, move this way, and if f is equal to e already, right, then oh shoot, it should be this dot f and this dot e. Right. So if they're the same, then this dot f minus 1 else so this is the same if this dot f is equal to this dot e, f equal to -1, this dot e -1, else I'm not sure. Let's see. What if I do, let's say, 10? Okay. Wait. Throw a bunch of things at it. Okay, it looks, maybe it's alright. Let's take a look, take a gamble. Use a single array and a lot of some manipulation of pointers, of 2 pointers. Yeah, I'm not 100% sure that this will work, but I guess we can give it a shot. Okay, let's try one more. Let's add more. You know, maybe every time get rare. Oh, that's the thing. Every time you get. Okay, how about we just say insert front. I don't know, we get a 5. See, that's it. That's just, it's hard. Okay, it's very hard for me to find out where things are. It's tough to do a test case. Okay, we're gonna give a shot. Oh, huh. I guess it does work. I guess it does work. I think I previously probably used 2 methods. One is linked to, yeah, one is linked list. Yeah, we have a head, we have a tail, and then oh, we have a doubly linked list. Really? We need double linked list? Yes, we need double linked list. Yeah, double linked list definitely do. This is probably a deck. Okay, so I put F and B in a different position. Is full if they're the same. Is empty if this. So insert front -1. Insert last +1. If it's empty, otherwise get front. Oh, because I point into the empty space. Yeah, I feel like this is the official solution, right? And I set them because I was trying to do a 0, 1. It didn't work for me. Alright, if you put 0, 1 front, and then because you're probably going the wrong direction. And it should be going this way. If front is here and is here, then we say front +1, because front goes this way. Right, so if front -1, yeah, I think it's a front -1. Oh, you always point into the, so if they're the same, right, you always point into the next available. So if they're the same, that's bad. Empty will be front +1, right? Yeah, I think that should be a better way of doing this. We do still need this. It's a better implementation. Right. F and E points to the next available front and position. So if it's empty, I don't have to consider this, which is full, which is false, right? Otherwise, we say this dot, actually we can do this first. This dot deck equal to value, move F forward. This is the same. We can say, then right, this should be good. Delete. I think delete front, this is the only thing we need to do. Right, delete front is the only thing we need to do. And delete end, it's the same. I think this is the only thing we need to do. get front. Yeah, because it's has to be +1 mod. I mean, we used this so many times. Okay. %s. Is rare. Okay, if it's empty. Empty is turn f +1 mod this okay is equal to this dot end. Should be a very simple problem. I have no idea why it becomes so complicated. Oh shoot. Stop B. Oh. That's B. Ooh, we have some issue. Insert front. Delete front. Oh, this. Wait, hold on. No, this shouldn't be the reason. Get front. Huh? Interesting. What did I do wrong? It looks same to me. Oh, K+1. That is the trick. Oh, wow. It's not K, it's K+1. Ah, k plus 1. Why k plus 1? Because the initial front and back is supposed to point in the same cell, but now you're pointing at 2 cells. That's why. And when it's full, right, when it's full is if the two meet each other, right? When the two meet each other, that's actually, you have, yeah, if they meet each other, that means it's full, because they are both pointing at the next available, right? Because E and F are pointing to the next available. Now if they both point at the next available, that means the next available overlaps, right? That means it's full. Otherwise, we have a next available for front, next available for the end, which means it's empty. Yeah, because if they point in at the same thing, that one is the next available, and we said that is, yeah, okay, so that's the reason. Should be k plus 1. We define full deck as, before we define F and E pointing to the next available front and end, which means when F and E meet each other, the deck is full. In this case, we have len deck -1 available spots. Thus, the deck itself must be of size k plus 1. Yeah, that is why it did not work for me earlier. I didn't think about this k plus 1 requirement. Now it will work. I mean, my other solution works, but because I did not use the deck, extra space in the deck to handle it, I have to set separate values for the front end, right? I have to set up separate values. This is just like the extra space. So I can keep the deck the same size, but then I have to do something like this, right? I have to do something like this. I have to check this. So it's just, a little bit convoluted, right? Convoluted. All right, that'll be it. I'll see you guys tomorrow. Adios.